Hello and welcome to the radio shop. I decided today we will start our series on the Yaesu FT-101, and on the bench we have our $10 flea market find. So I guess we will take a look at it and we'll start and do a preliminary of this radio, find out what all is wrong with it, what needs to be done to it, and do a little testing and see how to start on it. Now, with any radio like this, it's always a good idea to get your service manual out, and if you don't have the FT-101 service manual, you can go to the Fox Tango website and you can download a very nice service manual from there. I'll leave a link down below. But if you can, pick you up a copy of the paper service manual. You can still find these. As you can see, mine is worn. It's been used quite a bit over the last few years. But you know, you're gonna need your service manual. Next thing you know, you need to familiarize yourself with the radio, where everything is at in the radio. One of the first items to think about is the PA area and your transformer, and this is your voltage regulation area. Now, as always, remember there is live mains and high voltage inside this radio, so if you're following along at home, you do so at your own risk. Always take safety in mind and be careful when you're working on these things. Always keep the cover over the PA area so you don't accidentally stick your fingers in there and get a nasty bite. But we'll look at the right. Like I say, this is your transformer. Here, located on the side of the PA, is your regulator unit, and this is where some of your low voltages are fed through and filtered, and that's the only job of some of these capacitors in here. Rest of it is your different supply regulations. This is your receiver front end area. When you tune your pre-select, you'll see these three variable transformers move up and down. Here next to it, in this little plug-in module, is your RF board. This little small board is also known as the high frequency unit. And on this board you'll find your RF amplifier, your receiver's first mixer, your transmitter second mixer, and your heterodyne oscillator circuit. These are where those receive transistors are. They're FETs, 4-pin transistors. That is your RF amplifier. This section right here in the middle, this is your VFO unit, and in some models this is a EE. It does not have it. This is the extra economy unit, so it is missing the RF speech processor. That's why you see these two cables that are shrink wrap or not connected to nothing. This can be installed in the radio at a later date. The unit just above the VFO there, this little small board right here, this is your modulator unit, and in the modulator unit is where it contains our carrier oscillators, a ring modulator for single sideband, and our AM modulator unit. The next unit up above it with all the controls on it is your audio unit, and this is going to contain the microphone audio, the receiver audio amp, and your Vox circuit, and plus your CW side tone circuit. Our next board here on the edge where you'll see your CW filter and your single sideband filter. Sorry about the air conditioning running, but it's like 90 degrees outside, so you might have to put up with that noise for just a little bit. Okay, where were we? Alright, this module here contains your low frequency IF amplifier, your crystal filter, detector, and your AGC and S meter circuits. Here inside the shielded case behind the VFO is our high frequency IF unit. This contains the transmitter first mixer, the receiver second mixer, and it also contains the 5520 to 620 kilohertz bandpass network. Just in front of this is our noise blanker board. Now I know we didn't mention the regulator board, but I also wanted to mention this. This is also contains our marker generator, and what the marker generator is for. Here in front of the radio is our switch that says 25 kilohertz and 100 kilohertz. If you flip this down to 100 kilohertz and you roll this up to like 14,200, you'll get a tone and S meter deflection when this is in the it'll show it every 100 kilohertz. On 25 it shows every 25, and this is for aligning the VFO, you know, and setting your frequency. You can zero beat the single and get your VFO calibrated. Another good thing that this is good for, if you don't have a single generator and you need to check your receiver sensitivity, this is also connected to the antenna jack, so it serves as a single generator. So you can use this to align the receiver with. Now a lot of techs back in the old days would run out with a handful of boards, and even just by using the marker generator is able to repair these radios out in the field. So you know, a lot of these boards that we looked at are very easy to get to, because they'll simply unplug from the main unit, and you know, you got computer style fingers on it and you got a connector. Now the best way of doing this is having what's called cord extenders, where this would plug into the radio and then you can plug the board directly into the top of the cord extender. This gives you a working circuit, but you're able to get to everything. I do not have a set of those, and as long as I've been working on these radios, I've never had a set of them. Some of the boards, if that's really something I need to test, I've just sort of wires to the circuit board and run them up and tape them down to a piece of non-insulated material and do my test that way. It's crude, but it works. Another thing, when you're doing testing, if you have wrong one. If you have a probe with a long insulated tip, so you only got, you know, exposure right on the very end, you can get down inside this thing and check the voltages on those terminals without shorting anything out. So that'll help you a whole lot just by having. This one's actually a homemade one. I took an old probe, cut the tip off, drilled a hole into it, stuck in a tip that I needed, filed it down, brazed it in place, screwed it back in, and there we go. So one of the first things before even powering up the radio is that we're going to look at the schematic, and we're going to look around the power supply. And you can see all our voltages coming off the transformer and going through the various supplies. And the first thing we want to do is go in and ohm out the 600 volt, 160 volt power rails. These are two of the main power rails that's going to give the biggest bang if there's a problem detected. And what I mean is that if there's a capacitor or something that's failed and one of these supply rails, it's going to probably pop the cap and stink your whole place up. So what we want to do is just, you know, go in and ohm out the rails in this area, just to make sure that, you know, there's no very low ohm reading. So in our service manual, we can see our rectifier board. This is the PB1076B unit, and this board is located just underneath the transformer. It is sitting vertically in the radio, so you'll have access to the pins. You won't be able to get much down in it without, you know, pulling the board completely out. But I had some of the voltages highlighted. The low voltage 13.5, our minus 100 volts, our plus 160 volts, and our plus 600 volts. So we need to go in and check and just ohm out these voltages to make sure there's no shorts on our meter. So if our radio is sitting on the side, speaker towards the bottom, you can see here, this is our rectifier board. And Yaesu was kind enough to go in and mark all these voltages for us on the pins, so we don't have to sit there and guess. And we can see here, here's our minus 100 volts, our plus 600 volts, and our 160 volt. And on up here is our 13.5 volt. So we're just going to ohm these out and make sure there's no direct shorts on these. Okay, we'll go ahead and check our minus 100 volts, and these are DC voltages, and we're up around 26k. Now our 160 volt, well into thousands of ohms. And we need to check our 600 volt. Yes, and we're up into mega ohms. So we look like we're good on our main higher voltage ratings. And I'm not really worried about the lower voltages. If there's a problem in the lower voltage, it will blow the fuse. When I'm testing these radios, when I'm powering it on, I always use a fuse that is rated under the required rating, just in case there is some problems. It'll go ahead and take it out without, you know, doing any damage. So before we go any further, it's all, you know, radio's been sitting at this long. The controls are probably dirty. Now is a good time to go ahead and clean all your controls out. You have your clarifier control switch here on the front that you'll need to clean it. If you need to remove this board to get to it, just take out these two screws. Go ahead and clean your band switch. All your potentiometers, if you need to get on down in there further to clean some of them, take out these two screws and this one screw. You can lay your speaker panel over. It'll give you access to all these controls. But it's really important to go ahead and get them. There's no need of going any further without cleaning, and because, you know, that'll knock out a lot of problems right to start with. Okay, so now at this time we can go ahead and power up the unit and check the voltages on the power supply board. Now I do want you to know there's mains voltage and there's high voltage in this area that we're working on. So if you're following along at home, you do so at your own risk. So always try to keep safety first. I have the unit plugged into my Variac power supply, which goes through an isolation transformer. So you know, keep one hand in your pocket and test your voltages. So we're going to apply power. We're going to leave the heater switch in the off position at this time. Okay, the first thing I noticed is that the volume control does not work. I'm not able to cut the volume up and down. So what I did was roll the RF gain back. I already know where to look at that at, so we're not going to worry about at this minute. What we're going to worry about right this minute is our power supply readings. And I hope you can see the voltmeter. We'll start with our 13.5. And we're reading about 14.5. We'll go to our 600 volt. And it's showing about 730 volts. We'll look at our 160 volt. And we're at about 178. And then we'll look at our minus 100 volts. And it's rating about 177. Okay, we'll turn this back off. Now, we noticed some of the voltages was way off, especially our minus 100. It was rating minus 170 plus. We're not really concerned about that. We saw no shortage. We had a good high resistance rating. So, you know, it's just a state that the radio's in that we're going to have to work through and find out, you know, what is drawing current, what's not drawing current. And this is also tied to our regulator board, so we could have some problems in our regulator board, so we'll have to get into that a little later. Now that we're sure that our radio is somewhat working as far as power supply and our controls are clean, we can go ahead and start looking at the receiver. The receiver should always be the second thing you start troubleshooting. Once you know your power supply is somewhere close to where it needs to be, if you'll go through and start troubleshooting your receiver, once you get the receiver up and going, you'll have 75% of the radio done as far as having to worry about transmitting. Never attempt, you know, to go ahead and start troubleshooting the transmitter first. Once that receiver is up and running, you're just about home free, because you're only going to have a small section to worry about in the transmit circuits. A lot of circuits are shared between receive and transmit anyway, so once the receiver's, you know, is going, you'll be pretty much home free. Okay, so if you have the service manual in paper form, if we look at page 4-3, we'll see a block diagram of the unit. And like I say, you know, you always start with the receive first. So we're coming through our antenna line. We'll go straight into our RF unit, into our mixer unit, our noise blanker unit, our IF unit, modulator oscillator unit, and then into our audio unit. Now, as we know, when we were doing our initial test a while ago, I could not get the volume to turn down. So which one of these blocks do you think that we need to go to? That'll be all the way over here to PB1315, which is our audio unit. Now, one thing that I do like about the Yaesu 101 is you don't have to have a whole lot of test equipment to work on this radio. I've seen techs repair them with just nothing more than a voltmeter. You know, one of the most expensive pieces of test equipment I have is the IFR 1200. Well, when these engineers designed this radio, something that they did If you look over here at PB1314, which is the calibrator and regulator board, and if you see this calibrator board is tied right into the front end of the radio just before the RF unit. Now, so what does that mean? Well, this is like having a built-in single generator in this radio. And if this receiver is working correctly, when you engage this calibrator and it goes into the circuit, it will put an S9 on your S meter. Now the calibrator was designed to, calibrate your frequency. So like you put it on 14.000, turn your calibrator on, rotate your VFO, and you'll get a single. And then you can, tune that single in, 0 beat the single, and calibrate your outer wheel on your VFO. But with the brilliant design that they used, you can also use this as a single generator. And as you walk through the stages, once you get everything fixed and you get an S9 reading, well, your receiver is pretty much on par to where it needs to be. Okay, so the first thing we're going to do is power the unit back up. I have the RF gain set all the way down, and we'll turn it up till we get a little bit of noise. I'm going to go full volume on it. And as you notice, the volume control, there is no effect on it whatsoever. So let's start by looking at this AF gain and find out why it does not control the volume. So we're going to look at our main fold out schematic, and we're going to locate the volume control, or in this case AF gain. So we can see that here it says AFN. This is from the previous stage, and it goes right into the volume control switch. We'll follow it up, it'll go right on into pin 19 of our 1315 unit, which is our audio unit. And you can see also pin 17 is tied to it. Come right on up through a capacitor and straight into Q9. From Q9 we'll follow right on through, and this is into our audio amplifier. We'll go out on pin 4, and we'll follow right on down, and this goes through our phones jack and then into our speaker. So we probably should start checking from this input capacitor right on through to this preamplifier. So here we're looking at the front of the radio, and over on the left hand side you'll find your second card that's plugged in, which is PB1315, and is our audio card. Now it would be real nice to have what's called a set of card extenders, and what you do, you'll unplug the card, you'll plug the extender in, then you can plug the board into the top of it. And what this does, it gives you access to everything so you can check voltages. I've been working on these things for many years, and I've never had a set. I would love to get a set, but probably what I like to do is make my own set. And you can do this by pulling out these edge connectors in an old chassis that's beyond repair, and cut your circuit boards and make your own. They're not very hard to do. So the first thing we're going to do is pull out PB1315 and just give it a visual. I've said many times before in other videos is that it's always good to use your senses to help troubleshoot. So in this case, this is what we'll do on this board. So all you gotta do is just pry up on the board, and then you'll pull it right on out of the seat and pull the board out. So here we have the board out on the bench, and as I was saying, let me zoom in on it just a little bit. You know, a single will come in here to pin 19. There will be a jumper. It'll go straight into this capacitor and then into Q9, and from there you'll go into our audio amplifier. But I don't have to go no further in this board to even worry about troubleshooting it. I don't know if you can see this from this camera angle, but I'm going to zoom in on a couple of spots and see if you can spot what we think some of the problems may be. Remember I told you that you know, after it goes from pin 19 through this jumper, it's going to go into a first capacitor. Do you see anything wrong in this area? How about here? Anything catch your attention? How about there in front of the IC chip and over to the left hand side? And what is that laying on the board there? Take a look at this one right here. That one there. You see another one over here. There's another one there. You can see this one starting to come apart also. Now I have seen this before, but honestly I've never seen this magnitude of it, where these Mylar capacitors are just separating and coming apart. This is probably the worst case I have ever seen of this in my life. Whatever's caused it, I don't know if this board has had a lot of moisture exposed to it, and these old caps have soaked up moisture. I'm not sure, but they are really in bad shape. So now we know why our volume control or AF gain does not function, because we have a faulty audio board. So it looks like what we have to do is just completely rebuild this board, and we'll go from this to this, and it's the magic of YouTube. So we now have a board that's ready to be plugged in, and we'll give the radio a try and see what works. Okay, that's what's so good about having spare boards. Back in the day, a repair technician could go out with just a few tools and a handful of boards and get these radios back up and running without a whole lot of problems. So we'll make sure the volume control is turned down. We'll turn the RF gain down, and we'll power the rig up. And we'll turn off our RF gain, and we have no noise. And we're able to go all the way up to full volume. We're going to take the radio and we're going to turn our crystal calibrator on. And we can get about a S4 on the meter. What we're going to do is peak our pre-selector. On back the oil gain down just a little bit. And the receiver is functioning. So I'm going to set the RF single generator. Didn't mean to bump the camera. And you can see that we are pegged. And the single generator is wide open. Our receiver is faulty and our S meter is off. But there is receive. Your S meter is terribly off. So we do now have receive. I'm going to turn the generator down. That's about 5K. I can still hear it. Back up to 20K. And at about 5K I can start hearing it in the receiver. So now we know that we got to start out our antenna port and start working our way through the RF signal path and see if we can find out where we're losing our signal at. You know, it could be somewhere over here in the pre-selectors. It could be in the RF board itself. So we're looking back at our block diagram. We come in from our receiver and we go straight into our RF unit. And at this point we need to know if we have a good signal coming in through this whole circuit here. Now there is a few components here. You know, we have a pilot lamp that's up here, you know, just off the antenna. So we need to check through and walk through this circuit and find out what's going on. But before we do so, we want to do a couple of other tests just to see what state our radio is in. So one of the things I like to do at this point is just check and see if the transmitter does have any signal or any oscillation whatsoever. And we'll do this with the heaters off, and we'll check just the buffer. Now have the IFR tuned to the frequency on the spectrum analyzer, so we'll put it in tune mode. Zoom in on the spectrum analyzer. And all we want to do is just look for a blip, just to see if you know, the transmitter is even trying to come alive, because this will tell us a whole lot more about our circuit. As I flip the mark switch, I can see just a little blip come up. I don't know if y'all seeing it, so I'm gonna go through the pre-selector. Oh yeah, there we go. So our transmitter is alive, and to see if it's anywhere, you know, tracking with the frequency. We're going to just rotate our VFO. And we'll see we're going down in frequency. We'll bring it back up to 14,200, and we'll go up in frequency at about 10 kilohertz. So to start troubleshooting our receiver sensitivity, the first thing we could do is look at the schematic. And we can see here from our antenna port, the first part we go through is through a relay. Now this is showing on the schematic, you know, it's a one pole relay. In reality it is a double pole relay. There's two poles. We find a lot of times that this one pole gets glazed over, or you know, has a lot of carbon build up on it, and that will drastically drop the receiver. There is a modification to this relay that'll, you know, where you can use both poles, so it, you know, it's less impact on just one pole. And in another series we'll be showing you how to do that. So through our antenna port we got to go through our relay, and the next item is our pilot lamp. Now since this is the easiest part to go to, this is where we're going to start at next. Is pull out this pilot lamp and take a look at it and ohm it out, and it should, you know, be a real low ohm reading on that. Well, a pilot lamp is almost like a fuse holder type apparatus in the back. This one is broken, so I've already loosened the bulb up. I've checked the circuitry, and the circuitry is okay. It's just that the holder is broken. So we should have a GE, I think it's an 1892 bulb. So I'm gonna just looking at the back of this bulb. It looks kind of glazed over already, so I'm gonna clean this up and put it back in. Test our pilot lamp and see if make sure it's not open. We should have about 10 to 12 ohms on this lamp. And it's about 11.1 ohms, so that's good there. So as you can see, our relay is down inside the high voltage compartment. Now this is when you have to be very careful. Make sure, you know, the unit's off, your power is disconnected from the rig, and give the unit time to bleed down so there's no high voltage. Be very extremely careful when working in this area. So what we're going to have to do is pop this little band over that's holding the relay in, and we can pull this relay out and check it. So I got the relay out, and what we're going to do is pull the case off of it, remove the spring, and pull the pivot point out and have a look at the contacts on it. To do this, just simply pop these tabs and kind of hold the base of it. And the air conditioner just came on, so I know it's going to be making a lot of noise. Now you can pull this case right off. So let's get the light down here so I can see better. We're going to take our pick and catch the spring and pull it out. And this way we don't lose the spring. It stays right on our pick, so it don't go flying off into God knows where. Now just lift up the back of the relay, and you can pull it right out. Let me reposition the camera so you can see this a little better. So here we are looking at the relay, and you know I mentioned before that only one pole was used. Well, can you guess which pole is the one that's used? You see how nice and bright and shiny this one is? And look how dull and black that one is. So that's a lot of carbon built up on this relay, and it could definitely be dropping our receive single path down. So what we need to do is clean the center connector and then clean the other contact. So again, I flipped the actuator over, and you can see how nice and clean this side is and how black and dirty that side is. Now when you're cleaning relays, do not use sandpaper or a file. The best thing I like to use is a pencil eraser, because that will, take all this tarnish off. You can also put the relay back together. Take a piece of paper, coat it in deoxit or contact cleaner, and push the relay in and run it through back and forth, and that will clean it off. And then switch to the other side and engage the relay with your hand and run that paper back and forth. This way you're not damaging the contact. The contact has a coating on them. If you ever wear that coating out, the relay will go bad. So I went and took the eraser and cleaned the contacts on the center arm. And you can see they're nice and shiny on both sides now. And to clean the fixed contacts, I just use a piece of perf board, cut a small piece of a business card, put it on here, spray on some contact cleaner, stick it right down in here and work it back and forth like this. And you can see the amount of tarnish that it's took off. So we got the relay good and clean now, so I will put this back together. So here we're showing the two audio boards. These are PB-1315. This is the one that came out of the radio that has all the bad capacitors in it, and this is the one I replaced it with. Now, just looking at the two boards, you think they're pretty much identical, and they fairly are. Difference is the board that came in this radio is a PB-1315A. The board I replaced it with is a PB-1315B. So what does that mean? What is the difference? When this board came with it, we could not adjust the volume control. When we put this board in, we could adjust the volume control. Okay. Let's see if I can show you this. So we look in our service manual, and we look under the audio board. We'll go down here to where it says the double E, because this is a double E model. We have a mid, early, a mid, and a late model. And it gives serial ranges. The latest model of the EEEX, serial number 20,000. If we look over to the audio board, it says PB-1315B, and then the earlier models has the A right on up to the early B model, which had no designator on the end, and then the earliest two models has different numbers on the board. So I'm going to let you see two differences, or at least one difference in the boards. If you notice here, you see one jumper on this board. On this board, you can see that the jumper between pins 18 and 20. This board has no jumper between pins 18 and 20. So what this means is that some of the grounds on the AF gain control is changed around a bit. That's why this board would not work on the volume control. Not that, all the capacitors are bad, but it's missing that jumper. Now, another thing I wanted to show you on these audio boards. And this is the only sport I ever seen do this in the FT-101. Is you see all these Mylar style capacitors on here? I just want you to notice how they look. If you look here, you can see the outer cover is splitting and coming off. Now, I've seen this before, and normally when you see it, you'll see it on one or two capacitors, but I have never seen a single board with this many that were splitting like this. And I've checked a few of these capacitors, and some of them read like resistors almost. Now here's another board I happen to have that I haven't rebuilt yet, and you'll see it's the same way. Just about every Mylar capacitor on it is split. The funny thing is, on this board, every capacitor checks okay, even though the outer jacket is split on it. And you got to think about it. This, you got moisture in the air. Moisture gets into these things, and it penetrates the dip coating and swells it up and makes it crack. So it looks like these two boards has really been into a lot of moisture. I just want to show you that. That's two boards there, and that both of them has the same problem with the capacitors. On this board, you can see all the capacitors are good and knit. I replaced the Mylars in this one, I don't know, about 2 years ago, and they look okay. But now it's time to go ahead and change out all these electrolytics. And they're probably good, but it's always a good idea. You got to think about just how old this is. Just go ahead and replace out those electrolytics. So I hope you enjoyed walking through with me on the preliminary check of our $10 flea market find. And we'll have many more videos coming out for this series. Our next video will go through our fault tree in our service manual. It's pretty good detailed, and we'll go through our receiver, see if we can find out why we don't have proper receive, and work through that and get that back up and going like it's supposed to be. And we'll be using our main schematic to troubleshoot through. We'll also look at in future videos rebuilding the boards and doing various checks. We'll be looking at our AM filter, how this circuit works, how to modify the board to accept the AM filter. And another future video we'll be looking at our main multi-pin relay. You cannot buy this relay any longer. You can find used ones on eBay. They do not make a drop-in replacement relay that I know of, although a friend of mine does stock a replacement relay, but you have to change some of the wiring on there. So we'll be going through that, and if anyone needs this radio, we'll get in contact. Needs a relay, we'll get in contact with Chris and order some, and then we'll show you how to install them so they'll work properly. So I'd like to hear any of your comments down below. I'll leave some links down below also to the Fox Tango site if you never looked at that. They do a lot of stuff with the FT-101, and you can download your service manual there. So until next time, we'll catch you in the next video. See you now.